Hi everyone, in this video we're going to go through some fractions basics. There's been quite a few requests for this video from all of my different grades, so I'm going to put it all in one video. It should cover from if you're learning from them for the first time, right up to if you're revising for Methods Foundation. So in this video we're going to go through simplifying, adding, subtracting, multiplying and dividing. And as always, if you're okay with some of them and not others, just skip through to where you need to be. So as an overview, just to start with, when we're talking about fractions, we are talking about part of a whole. Okay, so a quarter, 3/4, 1/2. We might also be talking about mixed numbers where the numerator is bigger than the denominator. For this video, I will introduce mixed numbers like 3 1/3, show you how to convert them into fractions and then use them. But typically we don't use mixed numbers at all. So we're going fractions in this video and into decimals if you have a calculator. So just before we start, remembering that the top of the fraction is a numerator and the bottom is a denominator. You'll hear me refer to that throughout the video. I might also say top and bottom, depending how lazy I'm feeling. So let's get started. Okay, so we're going to start with simplifying fractions, and I've got 3 examples of fractions on the side there that we are going to simplify together. Now, the reason we simplify fractions is to give the final answer. So if you got to the end of an algebraic equation and said x equals 2 times 3, that's not really the final answer. We have to sort this out. So 2 times 3 would be 6. Okay, so our final answer is in its simplest form, and fractions are no different. So to get a fraction in its final form, we need to simplify it, which means we need to get it down to kind of the lowest form possible. So we're going to start off pretty easy. With these, there's lots of different methods, and I'll try and show you a couple for each one. But as long as you get to the same answer, it doesn't really matter how you do it. So whichever ones are easiest for you. So the first thing I do when I look at a fraction, when I'm simplifying, is I try and find the highest common factor. So the highest common factor is a number that they both divide by, and I try and go for the biggest one. And so here, for 4, some of the factors of 4 would be 1, 2, and 4. And the factors of 6 would be 1, 2, 3, and 6. So we're looking for factors that they have in common, and they both divide by 2. Okay, so what I'm going to do is I'm going to divide the numerator and the denominator by 2. Equals 4 divided by 2 is 2, 6 divided by 2 is 3. Okay, and then I look again, are there any other factors in common? So the factors of 2 are 1 and 2, factors of 3 and 1 and 3. 1 doesn't help us at all, it won't do anything. So that is the simplest fraction that we can get. Okay, let's try the second one. So I'm going to do this one 2 different ways. The first way, I'm just going to keep halving it until I get an answer. Okay, and this is everyone's favorite technique. So I know that they're both even, therefore I can half them. So half of 14 is 7, half of 20 is 10. Okay, I look again, I can't half them anymore because you can't find half of 7. We can, but it's a decimal and you can't put a decimal and a fraction in the same thing. And 10 I could, but I can't with 7, so there's no point. So that's one way of doing it, just plain halvesies. The other way we can do it again, we can look for factors. So factors of 14, 1, 2, 7, 14. Factors of 20, 1, 2, oh, let's test my brain, 4, 5, 10, 20. The highest common factor there is 2. I need to come up with a better example, one that's not 2. All right, so we divide both by 2. And that simplifies our fraction to 7 over 10. All right, this last one here, you can see it's an improper fraction, which means that the numerator is bigger than the denominator. But we simplify them just the same. I would not recommend you change them into mixed numbers because once they're in mixed numbers, they're a bit of a pain to mess around with. Whereas in fraction form, it's quite easy once you get the hang of it to multiply, divide, simplify, add, subtract. So if you can keep them in this fraction form, you'll find it a bit easier. So I'm going to play my halvesy technique. So I'm going to half, because they're both even, half of 28 is 14, half of 6 is 3, and I'm going to have a look and see if there's any more factors. So factors of 3, that's pretty easy, that's just 1 and 3. 14 doesn't divide by 3, so I know that I'm in the simplest form there. Okay, I'm going to do another example just because I've picked some terrible ones here. So let's try 21 over 28. Okay, now the first thing I notice, I can't do my half it thing because I've got an odd number there. So I'm going to have to think of some factors. And you don't have to write the factors down, you can just think about them. I'm just trying to show you what I'm thinking. So the factors are 21 divides by 1, divides by 3, divides by 7, divides by 21. Factors of 28 are 1, 2, 4, 14, 28. I know I've missed some there. Definitely missed some there. 7. Okay. So 4 and 7, 4 times 7 makes 28, 2 times 14, 1 times 28. Yep. So I've got a few common factors. I've got 1 and I've got 7. I'm going for the highest one. So I'm using 7. So I'm going to rewrite it, 21 over 28. I'm going to divide the numerator by 7 and the denominator by 7. 21 divided by 7 is 3. 28 divided by 7 is 4. Okay, so that's one where we didn't use 2. I'm also going to show you another one. My page is getting very messy, I apologise, where we're going to play the halvesy game for a while. So 50 over 100, most people will be able to look at this and know it's a half, but we're going to prove it. So we're just going to keep dividing by 2 until we work our way down. So half of 50 is 25, half of 100 is 50. Okay, so that's playing halves. Now I can divide by 5 for both. So 25 divided by 5 would give me 5, 50 divided by 5 would give me 10. Again, I can divide by 5, which is 1 over 2. Okay, so if you do this factor thing and you pick the highest common factor, you can do it in one step. Okay, so the highest common factor here would be 50. Or you can just keep dividing it by whatever you can divide it until you get right down to the lower numbers. So either one is fine, and you can use whichever one you want. So we're now going to look at how to add fractions. So I've put a little list up here, and we're going to follow that as a checklist every time until it kind of becomes like your thought process. So this is what I want you thinking about when you're doing it. We'll start it as a checklist and we'll just kind of let it fade away. So the first thing that we need to do is that we need to ensure all terms are fractions. So fractions, fractions, fractions. When we get down here, we're going to have to do an extra trick to make them all into fractions before we can add them. Okay, so you can only add or subtract if they are fractions. So let's start with the first one. We'll go through the steps slowly, and by this one over here, you should be pretty used to them and getting a bit bored. So number 1, ensure all terms are fractions. That's a fraction, yes. Okay, step number 2, we need to make sure the denominators are the same. So if you remember the denominators down the bottom, they're the same, yep. Okay, now we're going to add the numerators together. So we're going to go 1 plus 3 equals 4. So I've added the numerators together, tick. Leave the denominator as it is. So the denominator is 7, 7. Okay, and you're just going to check that makes sense. So we've got 1/7, we had another 3/7. Yes, we have 4/7. Okay, I should have one more step there that says simplify. So we can't simplify this one, but you should always simplify your fractions when you've got your final answer. So let's go again with the next one. So we're going to check, are they all fractions? Yes. Are the denominators the same? Yes. Add the numerators together. 1 plus 3 is 4. Done. Leave the denominator as it is. 8. Done. and then we're going to simplify. Okay, so here we can keep halving it, or we can find the highest common factor. So I'm going to halve it. I won't even do that. That's a bit too extravagant. So half of it is 2 over 4, half it again, 1 over 2. Okay, or you can highest common factor is 4 and go from there. So let's go again with this one. So step number 1, ensure all of them are fractions. Yes, tick. Make all denominators the same. We've got a problem. Okay, we need to make the denominators the same, and we can only do that using multiplication or division, and we only normally use multiplication. So what we're going to do, we're going to do it 2 different ways. I'm going to do it first by changing this fraction and then again changing this one. So if I want the denominators to be the same, I can do it 2 ways. I can make it into 5 or make it into 15. I can make them both into 30, but I'm going to make this one into 15. So how I'm going to do that, I'm going to try and think what would I need to multiply that 5 by to get 15, and that would be 3. And whatever you do to the denominator, you have to do to the numerator and vice versa. So my new fraction is 6 over 15 plus 3 over 15. So I'll finish this one off and then we'll do it the other way. So that is now a tick. The denominators are the same. I'm going to add the numerators together. 6 plus 3 is 9. Tick. I'm going to leave the denominator as it is, 15. Tick. And I'm going to simplify. So they both divide by 3. 3 over 5. Done that one as well. Okay, another way you could have done it, let me just write this up here again. Another way that you could have done this one, oh, it would help if I wrote it correctly, is if you look over here, we could possibly divide this by 3 to get it back to 5. Now this works in this case because there's a 3 on the top. If there was, say, a 4 over 15, you couldn't divide that by 3 because the top and the bottom wouldn't divide nicely. But for this one, it's going to work, so we're going to try it. Divide by 3, which gives us 2 over 5 plus 1 over 5. So they're both fractions, tick. The denominators are now the same, tick. We're going to add the numerators together, so 2 plus 1 equals 3, tick. Leave the denominator as it is, 5, tick. Simplify, can't, tick. Okay, so that way was probably quicker, but as I said, if that was a 4 or a 7 or anything else that didn't divide nicely by 3, you'd have to do it the other way. So that one had kind of changing one fraction to get it to work. These next two, you've got to change both the denominators to get them to work. So let's have a look. If I run out of colours, we've got grey. We need to get those to be the same. Now we can't multiply 2 by anything to get to be 3. 3 doesn't go into 4, so we've got to find a number that they both go into. And the quickest way to do that is normally just to multiply them together. So 2 times 3 is 6. Let's change them both to be 6. So I'm going to go through my checklist. Sorry, I forgot about that. So are they both fractions? Yes, they are. Are the denominators the same? So let's change them both into 6. So if I want 2 to be 6, I'm going to multiply it by 3. And whatever I do to the bottom, I've got to do to the top, which gives me 3 over 6. And if I want this 3 to be 6, I've got to multiply it by 2. Whatever I do to the bottom, I've got to do the top, which makes it 2 over 6. Okay, so they're both fractions. The denominators are the same. We're going to add the numerators together. So 3 plus 2 is 5. Tick. Leave the denominator as it is. 6. Tick. Simplify. Can't. Tick. Okay, we'll go again. Again, they're different denominators. Let's just multiply the denominators together. So we're going to turn them into 12. That will always work, that multiplying them together, but you might have a bit of more simplifying to do if there was a lower common factor, but you'll always be able to do this method. So we're going to try and get them to be 12. So to get 3 to be 12, I'm going to times this one by 4, which gives me 4 over 12. And to get this one to be 12, I'm going to times it by 3. So 3 over 12. Okay, they're both fractions, tick. The denominators are now the same, tick. Add the numerators together. 4 plus 3 is 7, tick. Leave the denominator as it is, 12, tick. Simplify, can't, tick. So we should be getting pretty used to that now. This next one throws a bit of a spanner in the works because we can't actually tick off that first one. They're not both fractions. So you need to make them into fractions. So any number, any variable, anything can be written as a fraction by just putting it over 1. Okay, so if you want to change something into a fraction, just pop it over 1. And now we want these denominators, oh, that's a tick. We want these denominators to be the same. So all I'm going to do, I'm only going to change this fraction. I'm going to times the top and the bottom by 4, and I'm going to change that fraction into 12 over 4. Okay, so tick, denominators are the same. We're going to add the numerators together. Tick. We're going to leave the denominator it is, which is 4. Tick. We're going to simplify. We can't. Done. Okay, and this last one, I've popped a mixed number in there just to annoy everybody. We need to change the mixed number into a fraction first. So this is kind of 3 full halves, plus you've got another half. So how you do it is you multiply the whole number by the denominator, and then you add the numerator. So 3 times 2 is 6, plus 1 is 7. Okay, and then we're going to go as normal. So they're both fractions now. Tick. Denominators need to be the same. Let's change it into 4. Sorry. And we're going to do that by times and by 2. Sorry, I'm allergic to fractions. Right, so we've got now 14 over 4 plus 1 over 4. So they're both fractions. The denominator is now the same. We're going to add the numerators. So 15, 4, done. All right, so that's adding fractions. So now we're going to subtract. You can see I haven't put as many examples on subtracting fractions simply because it's so similar to adding that we don't really need to go over it too much. So you can see all the steps here are exactly the same except for number 3 here says subtract the numerators instead of add the numerators. So that's the only difference. So we're going to go through these 3 examples. So step number 1, we're going to make sure they're both fractions. Yes, yes, tick. We're going to make sure the denominators are the same. Yes, yes, tick. Subtract the numerators. So we're going to go 4 minus 2, which is 2. Tick, oh, tick. Leave the denominator as it is. 7, tick, simplify, can't. All right, so very, very similar. We're just taking it away. And you might end up with negative numbers. That's okay. So this one here, let's go through it. Ensure they're all fractions. They are, tick. Make the denominators the same. Okay. So we're going to multiply them together, which gets 21, and we're going to change them both into 21. So this one gets multiplied by 7 and 7, which is 14 over 21. And this one's, by 3. So 9 over 21. So the denominators are now the same. Tick. Subtract the numerators. 14 take 9 is 5. That's done. Leave the denominator as it is. 21. Done. Can we simplify it? No. All right. So very, very similar. And the last one here, I've put a mixed number just to practice. So to turn it into a fraction, we're going to go 2 times 7, which is 14 plus 1, 15 over 7 minus 3 over 7. Okay, so they are now both fractions. Ta-da. We're going to make the denominators the same. They already are. Tick. Subtract the numerators. So 15 take 3 will give me 12. Done that. Leave the denominator as it is. 7. Done that. Can I simplify? No, because 7's a prime number and doesn't really do much. Okay, and that's it. So if you can add fractions, you can subtract. If you can subtract, you can add. They're very, very similar. Luckily for all of us, multiplying and dividing fractions is actually easier. So let's get on to that. Okay, so multiplying fractions is the easiest one, and you can see the steps have changed. So we're going to check first of all that both are fractions. Yes. We're going to multiply the numerators. So 4 times 2 is 8. Done. Multiply the denominators. 5 times 3 is 15. Done. Simplify. Can't do that. Okay, so you're just multiplying straight across. You multiply the top together, multiply the bottom together, simplify if you can. So let's try the next one. We're going to ensure they're both fractions, which they are. Tick. Going to multiply the numerators. 3 times 4 is 12. Done. Multiply the denominators. 7 sevens, 49. Done. Simplify. We can't. Okay, so very, very easy. The only trick comes when there is a non-fraction to start with, and even then it's not too bad. So ensure all terms are fractions. We're going to use that trick from before. You can put anything over 1 and it's now a fraction. So we've turned them into fractions. I'm going to show you a shortcut for this in a second as well. So we've done that. Multiply the numerators. 3 times 2 is 6. Multiply the denominators. 1 times 3 is 3. Simplify. They both divide by 3. Actually, 6 divides by 3, so it's just 2. Okay. A shortcut for this, if you've got a mixed number out the front, like that, you can just multiply the number by, if you've got a whole number at the front, you multiply the whole number by the numerator, so just 5 over 2. Okay, that's a shortcut because the 1 multiplying there doesn't do much. So if you want to use a shortcut, the whole number multiplies by the top. All right, and that's it. That's multiplying. Dividing is a little bit trickier, but not much. But let's get on to it. Okay, now dividing has one extra step, which is where we have to invert the second one. So we're going to go through this checklist again. If you're going to write anything down from these slides, I'd go the steps until you've practiced them so much that you've memorized them. So let's go through them one by one with the first fraction here. First thing we're going to do, we're going to ensure they're both fractions. Yes, yes, tick. I don't know why my pen's doing this. Okay, the second step, flip the second fraction upside down. So we're going to leave the first fraction alone, and you're going to flip the second one upside down. Okay, I'll show you the rest and then I'll show you the trick to remembering it. So that's called inverting, tipping the second one upside down. Don't tip the first one upside down. You will get your answer upside down if you tip the first one. You need to tip the second fraction. Okay, and if you've got multiple fractions, do them 2 at a time and just flip the second one. So we need to change the divide to a multiply. Done. Taking the divide, change it into a multiply, and then it's just like multiplying. So we're going to multiply the numerators. 4 times 3 is 12. Multiply denominators. 5 times 2 is 10. We're going to simplify. They both divide by 2, so 6 over 5. Okay, so the way that I've heard students remember this is tip and times. So you tip the second fraction upside down and then you times them, or invert and multiply. Second one sounds a bit more impressive if you're an older student, but both of them work. So the second one, let's have a look. Are they both fractions? Yes. We're going to flip the second fraction upside down. Done. We're going to change it from divide to multiply. Done. Multiply the top, so 9. Multiply the bottom, 50. Done, done. And simplify, which we can't. Okay, once again, the only real trick is when you've got a whole number. But if you follow these steps every time, it makes it a lot easier. So step number 1, we're going to make sure they're all fractions, and we're going to do that by changing that into 3 over 1. Second step, we're going to flip the second one. So 3 over 1, 7 over 1. Done. Change the divide to a multiply. Done. Multiply the numerators, which is 21. Multiply the denominators, which is 1. That worked out quite nicely. 21 divided by 1 is just 21. Okay, so dividing fractions isn't that bad. You've just got to make sure that they're fractions first, not mixed numbers, not whole numbers, not decimals. If they're fractions to start with, they're really, really easy. And that's it. So that's all the stuff I have for you for fractions. If you want any others added to it, just let me know and I'll pop them in.